Hi,
Hello, Fatima. How are you doing?
thank you.
So I am an associate professor of astronomy and space science at the UAE University in the UAE, which is situated in the city of Al Ain in the Emirate of Abu Dhabi. Ask about meaningful questions on existence. Where did we come from? How was everything created? And what is going on in this entire system, in this universe, on this earth? So I think I was flooded by all these questions when I was doing my master's and PhD. And that was the spark that I said that, okay, that is what I want to do for the rest of my life. And this is what I'm trying to chase and run after. I have been part of a group that detected the first ever tera electron volt emission from a GRB. So that was for the first time I was part of that team. So that's something that we were all proud of. In addition to that, I think the NASA project that I'm a small part of, I feel very proud to be a part of that project because that is something uh, really, really significant, and uh, it was one of my dreams to be a part of something like that. Honestly, right? A project of that size, sending a new mission to the to a reasonably large distance in space. It's going to be at L2. So graph, my project that I did in the UAE at the UAE University, that was an example of an interferometer. It had 256 individual elements, which are dipoles. It was a simpler type of antenna. So it is an interferometer that gives you higher resolution compared to, let's say, a single antenna or a smaller antenna. So the purpose that I wanted to do this project was to actually be able to have this interferometer for relatively high resolution radio astronomy that we wanted to observe. There are many instruments and telescopes out in the world, right? But I believe and I had an imagination that you need to have this kind of a multi-purpose type instrument with which we can study, we can conduct studies within various subdomains of space sciences: astronomy, space weather, solar physics, and things like that. So I think that an instrument like that would be something well suited for making contributions into the overall advancement of space sciences. So you can imagine that there are 5,000 satellites around the Earth right now. And if you count everything, the total number is in millions. There are millions of objects around the Earth. And there is a risk, and it is a risk for sustainable space exploration. So the challenge is that you need to be able to observe all these objects using, let's say, instruments on the ground and on in space. The first thing is that you observe and detect these objects, and then you study their astrodynamics, you study their orbits, right? And then you try to see that, what are the things that are required to be done to avoid collisions, for something to fall on the ground on human population. Because if something is randomly coming down and you don't track it and you don't know about it and you don't have the awareness of it, it might fall on a human population, right? So we are trying to build a system with my collaboration that can actually conduct this kind of a study, studying all of these objects in the near earth space, so that we are aware, that that's the word in the main title. We are aware of what is going on in the near earth space. I think that the volume of data that we are going to have in the near future it is going to be almost impossible for humans to process all of that manually or using simple or basic or conventional tools that we have. You would need to have some form of automation or some intelligent mechanism or some kind of intelligent system that can do most of the laborious work or the manual work so that that volume of data can be processed and useful insights can be taken out of them. But again, I should point out here, it does not mean that it's going to replace humans. I'm quite excited about the results that James Webb Space Telescope is producing. Right? It is actually producing some quite unexpected results. Let me give you an example. So, James Webb Space Telescope observed and detected a few galaxies in the early universe, which scientists did not expect them to be there. But Emmer's Mars mission was the flagship large scale mission that they wanted to do. But on the other hand, if you imagine that we are just at the tip of the iceberg, there's a lot about the universe that we don't know. We still don't know how to, travel to a distant star. We have never gone beyond the solar system. So perhaps this phenomena of artificial intelligence, because we know it's growing, I don't see it as something that should become, the masters of humans or something that goes beyond humans. I see something which I call the natural plus artificial intelligence, NAI. That's something that I imagine in my head. That artificial intelligence, with its efficiency, with its precision, with its computing power, because it's not human, so it won't get tired as long as you have enough resources. So it's going to be the merger or a combination of human intelligence plus the AI, which is going to be the driver or the accelerator for the science and technology developments in future. I think that one thing that I would like my younger self to do, if I would ever able to talk to my younger self, but I can mention it to people who are younger than me. When you start building the understanding of any topic in astronomy, try to go as deep as you can. Don't just focus on the surface level understanding, because many times human beings have a tendency or have a habit. You look at something, oh, okay, I understood this. That's enough. You know, I believe that people achieve success when they do something that they love.